Lesson 63, Solving Systems of Linear Equations by Elimination. Example 1. Solve the system by elimination and check the answer. So what we're going to be doing is literally, let me get my pen out. We are literally going to eliminate a variable so that we can solve. We have solved systems by graphing. Okay, we have solved systems by substitution, and now we're going to practice solving by elimination. So, to be able to eliminate a variable, what we have to have is a coefficient with an opposite sign, but that's the same. So they have to be opposites. So here, my x's, okay, I have a coefficient of 3 and a coefficient of 6. Those are both positive, and they're not the same coefficient. So that won't work. Here, I have a positive 7 and a negative 7 for y. Those are opposites, and that's what I need, because what I'm going to do is I'm just going to add these two equations together. So I have 16 plus 11 gives me 27, and that's equal to 7y minus 7y cancels. 3x plus 6x gives me 9x. To get x by itself, I'm going to divide by 9 on both sides, and I'm left with x equals 3. Well, now that I know that x equals 3, I can take it up here and plug it into one of my original equations. So I have 3, and instead of x, I'm going to put 3, plus 7y equals 16. 3 times 3 is 9, plus 7y equals 16. Subtract 9 from both sides. I have 7y equals 7. To get y by itself, I divide by 7 on both sides. So I end up with y is equal to 1. So my solution is 3, 1. To check the answer, I can take this x and y, plug it in, and make sure that it works, which I should probably do because the directions tell me to. So we'll go back and do that real quick. I have 6. Instead of x, I'm going to put 3. Minus 7. Instead of y, I'm going to put 1. Equals, not 7, it equals 11. This gives me 18 minus 7 has to be equal to 11. 18 minus 7 is 11. That is equal to 11. It checks. Okay, on this one it says to solve the system by elimination. And this time, looking at my x's, I have negative 2 and negative 2. Well, those are this exact same coefficient. I need them to be opposite signs. Here I have 2 and negative 7. Those are completely different coefficients. So the easiest thing for me to do would be to make one of these a positive. And I could make it a positive by multiplying by negative 1 on both sides. Because what I do to one side, I must do to the other. And as long as I do that, it hasn't changed the value. So I'm going to distribute that negative 1 to everything. So negative 1 times negative 2x is going to give me 2x. Negative 1 times 2y gives me negative 2y equals 18 times negative 1 is negative 18. So now this equation is gone because it's become this equation, and now I have an opposite coefficient. So I'm going to go ahead and add these. I have 9 minus 18 gives me negative 9. Negative 7y minus 2y gives me negative 9y. Negative 2x plus 2x cancels out, so I can divide by negative 9 on both sides. And I'm left with y is equal to 1. Well, since y is equal to 1, I can take that and plug it in up here. So I have negative 2x minus 7. Instead of y, I'm going to put 1 equals 9. So I have negative 2x minus 7 equals 9. I need to add 7 to both sides. So I have negative 2x equals 16. Divide by negative 2 on both sides. And I'm left with x equals negative 8. So my solution is negative 8, 1, because it's always xy. Okay. Alright, wants me to solve the system, and I'm going to do the same thing that I've been doing. However, I have to have it in standard form, and I hope you remember that standard form is ax plus by equals c, which just means that I have x and y on the same side. The first equation, I do have x and y on the same side. The second equation, I do not. So to change that, I'm going to have to add 2y to both sides. Okay, so when I do that, this will cancel. I have 5x plus 2y equals 6. Now I'm going to stack this other equation underneath of it so that I can work. So I have 3x minus 6y equals 18. All I've done is rewrite this equation right here. Alright, so I have 5 and 3. Those are totally different coefficients. I have 2 and negative 6. Totally different coefficients, but they are opposite signed. So the easiest one for me here would be to multiply on top to get this to be a positive 6. So what I need to multiply to get this to be a positive is to multiply by 3. Or not to be a positive, excuse me, to be a 6 is by 3. So I'm going to take this times 3 on top and bottom, or not top and bottom, on left and right on both sides. So then I can distribute. So I get 3 times 5x is 15x plus 3 times 2y is 6y equals, the 6 times 3 is 18. So now I can add these. So 18 plus 18 is 36. Negative 6y plus 6y, those cancel out. 3x plus 15x gives me 18x. To get x by itself, I'm going to divide by 18 on both sides, which leaves me with x is equal to 2. So I can now take this, plug it in up here. So I have 3, instead of x I'm going to put 2 minus 6y equals 18. This gives me 6 minus 6y equals 18. Subtract 6 from both sides. Negative 6y equals 12. Divide by negative 6 on both sides. And I'm left with y is equal to negative 2. So my solution is 2, negative 2. Final answer. Solve the system of linear equations. I'm doing the same thing on this one. I have a positive and a negative, but totally different coefficients. Here I have a positive and a negative, but totally different coefficients. So what I need to do is I'm going to have to figure out what I need to multiply to make these work. So since I have opposite signs, and they're both totally different, I can do either x or y, it doesn't matter. So I'm just going to choose to do x. And to get these to be the same number, okay, I'm going to have to use 10, because 2 doesn't go into 5 evenly. So I'm just going to go multiply the top by 5 on both sides. And I'm going to multiply the bottom one then by 2, so I get 10 for this one also. So I get 10x, 5 times 2y is 10y equals negative 8 times 5 is negative 40. 2 times negative 5x is negative 10x. 2 times negative 3y is negative 6y equals 14 times 2 is 28. So now I can add those two equations together. Negative 40 plus 28 gives me a negative 12. 10y minus 6y gives me 4y. And 10x minus 10x cancels out. So to get y by itself, divide by 4 on both sides, and I'm left with y is equal to negative 3. So since y is equal to negative 3, I'm going to take that and I'm going to plug it in up here to an original equation. So I have 2x plus 2, instead of y I'm going to put negative 3 equals a negative 8. So 2 times negative 3 gives me negative 6. Bring everything else straight down. So this, I shouldn't have written like that. Opposite signs gives me a negative, so I'm going to add 6 to both sides. So I have that 2x is equal to negative 2, divide by 2 on both sides, and that gives me that x is equal to negative 1. So my solution is negative 1, negative 3. Last example says a museum sells 280 tickets in one day for a special exhibit. A regular ticket costs $20 and a student ticket costs $14.50. How many student tickets did the museum sell if it made $4,918? So they tell us that they sold 280 tickets. And of those tickets, we know that some of them are regular and some of them are student. So it asks for student tickets is what we're looking for. So I'm going to say that regular tickets plus student tickets has to equal 280 tickets. That has to be my total. Then, move this somewhere where I don't need it, there we go. And then I know that a regular ticket was $20, so I'm going to put 20R plus 1450, so I'm going to put 14.5S is equal to the amount that they want to make, or the amount that they made, which is $4,918. So what I want to do is I want to get a variable by itself, and I hope that you can very quickly see that this is the one that's going to be easier. So I'm just going to get S by itself by subtracting by R on both sides. So I have S is equal to 280 minus R. So I'm going to plug this information in. That is not what it wants me to do on this one because we are using elimination. But this just goes to show that you can do it any number of ways, okay? We've talked about doing it by graphing, we've talked about by substitution, and we've talked about by elimination. So, I'm just going to go ahead and finish it by substitution. Sorry about that. What you could have done, should have done, is multiply this probably by -20, so you could cancel your R's really easily. Maybe we should go ahead and do that. I'm so sorry. I don't know what I was thinking. -20 times RS, and then I have to multiply on the other side also. So I have -20R minus 20S equals, and then 20 times, -20 times 280 is going to give us 5600, and it's going to be negative. So then I'm going to stack this other one underneath. So I have 20R plus 14.5S is equal to 4,918. So I can add those two together now. I can see that these are going to cancel very quickly. And then I'm going to end up with negative 5.5S equals negative 5,600 plus 4,918 gives me negative 682. Divide by negative 5.5 on both sides. So I'm left with S equals 124. So this is 124 student tickets, and I believe that's what they asked for. Let's go back and check our question. It said, how many student tickets did the museum sell if they made that much? And that's what we found. You could find how many regular tickets by taking this and plugging it into that original equation, but that is all. So I hope that you've taken good notes, and I will see you in class tomorrow. Have a good night.